minus, this is 4 times 3, right? The square root of 9 is 3. So 4 times 3 is 12 rad 3 plus 2 rad 3. Okay? 4 times 3. Okay, so simplify that. 2 minus 12 would be a negative 10. Negative 10. Did I say that right? Yes, 2 minus 12 would be a negative 10. Negative 10 plus 2 is? Okay. Negative 8 rad 3. Questions on that? Okay. Yes.
I forget what variables are able to go where depending on
yeah. So whenever you simplify on number 28 like this, you have the cube root, right? And that's where I think a lot of people get confused is they start looking at it as a square root and they try to break an 8 down into a 4 and a 2. Neither one of those is a perfect cube. What's a perfect cube?
9. 2.
That's a perfect square.
8.
8, right? So if we're going to break this down, you're looking for the perfect and the not perfect here. That 8, the whole thing can go on the perfect side. Then you have this x to the 6th. What's the question you should be asking yourself? How many times could it go into x to the 6th? So 6 divided by 3, does that work? If it's divisible by 3, you put the whole thing on the perfect side. Okay, so we put all 6 there. Is 10 divisible by 3? No. Is 9 divisible by 3? You just work your way down, right? So this is going to be y to the 9th, which leaves us with what under the non-perfect side? Y. Just y to the 1st, okay? So now we can simplify this. What is the cube root of 8? 2. 2. What's the cube root of x to the 6th? X to the 2nd, right? You're just dividing. 6 over 3 is 2, so x squared. And then y to what power? 3. The 3rd. And then you still have that cube root of y. Okay. Any other ones that are screaming at you right now? What's 31? What do you do for 31?
That's what I got a question about. Is that a times?
That is a times. Sometimes it just turns it into something else. That normally will just be a dot for you. Yeah, you're going to multiply those two things together. So 5 times 20 is 100. What is x times x squared? X cubed. You add them when you're multiplying with the same base, right? And then it's y to the 6th. Okay, so these ones are a little strange because you first multiply, so you make it smaller, and now we break it down again, make it bigger before we can really finish our simplifying. Perfect square versus non-perfect square. In terms of 100, what's going to go on the left here? 100, the whole thing. You can take the square root of 100. Okay, x to what power? X to the 2nd. 3 is not divisible by 2. Remember, there's essentially a 2 there. It's a square root. So x squared, which means there's one x that's not perfect. And then y to the 6th, how many? The whole thing, y to the 6th, right? Because it is divisible by 2. Okay, so then you simplify that. That's 10 x, y to what power? The 3rd. Divide by 2, and then you still have the square root of x. Okay. 35. Yes. And I'm going to do 34 also, but we'll start here. Okay, so on these ones, number 35, when you have an expression and you're trying to get the radical out of the denominator, what do you do?
Different sign.
The opposite sign, right? The conjugate. So it was 5 minus rad 3. We're going to multiply by 5 plus rad 3. So 5 plus rad 3 over 5 plus rad 3. Do you remember the shortcut? You square the first and last. a squared and b squared, and you subtract them. Do you have to do the shortcut?
No.
What could you do?
Foil.
You could FOIL it, okay? So if you want to FOIL, FOIL, but this is the shortcut. So this would be, if we take the shortcut, 5 squared minus the square root of 3 squared, right? We square both of those terms, and then we subtract them. That's going to come out to 25 minus 3. So you're going to have a denominator of 22. Okay, what do you do up top? You have to FOIL it. There's no shortcut for that. So we're going to FOIL. So this is 10 plus 2 rad 3 plus 5 rad 3 plus what? 3. The square root of 3 times the square root of 3 is the square root of 9, if you will, which is 3. Right? So this is going to be 10 plus 3, so 13. And then 2 rad 3 plus 5 rad 3 is 7 rad 3. So your final answer, because there's nothing that you can simplify there, looks like this. 13 plus 7 rad 3 over 22. Okay. Okay, so that's if you have an expression in the denominator. 5 minus a radical, 5 plus a radical, something minus something plus a radical. What if all you have in the denominator is a radical? How do you get the radical out of your denominator? You're going to multiply by that radical over itself. What is your numerator at this point? Five x or 6x? Yeah, we're multiplying, right? So this is 8 times the square root of 6x on top. What's your denominator? 2x, right? The square root of 2x times the square root of 2x is the square root of 2x squared, which is 2x. It's always the radicand. It's always whatever's underneath. Okay, and then the last thing you can do, can you divide those x's? No. Can you divide 6 and 2? No. Can you divide 8 and 2? Yes. That one you can, right? Because those are whole numbers. So you get 4 times the square root of 6x over x, and that's as far as you can go with it. Do you have one, or you want me to keep picking? I'm happy. 32. Okay, so this is another one of those, sorry, again, this should be a dot, but it's times. If you multiply, you can multiply the numbers out in front. 2 times 5 is 10. And it's the square root of 3 times 15 is 45. What's x times x to the 5th? X to the 6th. And then y to what power? The 5th. Okay, so now we're going to break it down. Perfect square, non-perfect square. Please don't forget about your friend out in front. What perfect square on the left? 9. And a 5 then on the non-perfect side. X to what power on the left? 6. It has to be divisible by 2, right? Because this is a square root. So 6 divided by 2 works. Y to what power? The 4th, with just one y left over on the other side then. This becomes 3x to what power? The 3rd. Divide by 2. Y to the 2nd. And then you still have that 10 out in front. So it's 30 x cubed y squared times the square root of 5y. Anything else on that page 28 through 37 that you want to see right now? I feel like we've touched a little bit of everything, yeah.
Sorry, can you zoom back into 32?
Yes. I am recording this, by the way, so I'll try to post it in a little bit and then you will have access to it. Okay, let's jump to the middle page here. Get 27.
Can you go back to 31 for a second?
Can I do it in a little bit?
Yeah.
I want to just keep moving. I'll show you at the end what we've got there. 27. What do you do here? First step is to isolate your exponent, right? How do you get an exponent by itself?
Reciprocal.
Well, it's make sure there's nothing out in front and nothing behind, right? Is this isolated?
Yes.
Yeah.
Yes, this one is isolated. So some of you, I think was it the quiz, had like this. These weren't the numbers, but there was a 2 out in front. That's not isolated. So you had to divide by 2 first, and then you could do the reciprocal, okay? This one is isolated, so that's not the case on this one. The parentheses are fully to that 3/2 power, okay? So now you do the reciprocal, which would be take it to the 2/3 power. So 8, well, you don't need those parentheses. We'll just write it like this. 8 to the 2/3. This goes away. That's 1. So really on the left, you just have 7x minus 3. 8 to the 2/3 power. Easiest way to do that is what?
Cube root.
Put it in your calculator. 8 to the 2 divided by 3 power. It will tell you what that number is. If you like the process, do the process. This would be the cube root of 8 and then square it, right? What's the cube root of 8? 2. 2 squared is
4.
4. Is this a plus or minus situation?
No.
No, we did not square root, right? We cube rooted. Cube roots do not do plus or minus. So we're going to add 7. Sorry, we're going to add 3, which is going to get us 7. So 7x equals 7, divide by 7, so x is 1. Okay. Ooh, how do you rewrite this? 25. 8 to the 3/5 power. Remember, this is the root. The root goes down. This is the power. The power goes up. A to the 3/5 power. How do you write this in radical form? Is it a square root or a cube root? It's a cube root. And then you either square it here or you put parentheses around the whole thing and then square it. It doesn't matter. They're the same thing. So whichever one you prefer. What happens when a radical equals a negative? No solution, right? If it's this, 6x plus 1 equals a negative 5, you say no solution. This one, you would isolate, add the 5, so you get the square root of 6x plus 1 equals a positive 5. Okay, what do you do from here?
Square both sides.
You square both sides. So when you do that, 6x plus 1, the radical goes away, equals 25. Is this a plus or minus situation?
Yes.
Yeah.
If you square both sides?
Oh, wait, no.
Only if you square root both sides, right? Because a square root could be the positive or the negative version of that value. So then from here, you would just subtract 1 and divide by 6. Okay.
About 22.
22? Yes, let's do 22. You know what you guys did on the quiz? A lot of you told me that your number becomes 8 because you took this 4 and you multiplied it by 2. And that is not what you're doing. 4 is a power, right? So you're saying 2 to the 4th power x to what power? What do you do with these two numbers? You multiply them, which is why I think so many people take 2 times that number, because you do take the exponents times that number, but you do not take, I mean, if you're taking the exponent, think of 2 as 2 to the first, right? 2 to the first times, or 2 to the 4th power is 2 to the 4th. So multiply these. X to the 5 to the 4 is x to the 20th. You add them if they both have an x. You multiply them if there's one x and it's a power to a power, okay? So x to the 20th, y to what power? The 12th, and z to the, what is z to the 0?
0.
It's 1. So you don't even have to write it down, okay? It's not going to change anything if it's 1. So this is where you're at. What's 2 to the 4th power? 16. 2 times 2 times 2 times 2, or let your calculator figure that out for you. So that's 16, x to the 20th, y to the 12th. Okay. 19 or 20? They're fairly similar. Raise your hand if you want 19. Raise your hand if you want 20. 19. Okay, so this one, there's a couple ways you can do this. Your calculator will do a lot of it for you. Or if you would prefer to do the mental math, you can do the mental math yourself. But you are multiplying both of those fractions by 24. So if you want to think of it in terms of it's a negative 2/3 times 24 over 1, if you will, that is negative 48 over 3, which is a negative 16. So right now, on the top, you have x to the negative 16th power. Again, you can plug into your calculator negative 2 divided by 3 times 24, and it will tell you that same number. So that's up to you. On the bottom, you are doing 3/4 times 24. So again, if you want to multiply across, you can, or if you want to plug that into your calculator, you absolutely can. That comes out to 18. And that's a denominator right now. What's the issue here? There is a negative exponent, and we don't like negative exponents. So when there's a negative exponent, what do? You move it. Do you move both things right now?
No.
Only the negative, okay? So x is going to move down, x to the 16th. Y is going to stay put, because y is not a negative exponent. What's on top?
1.
1.
Even if
Ryan.
you put y to the negative 18, isn't that correct? At the top.
Theoretically, this could be y to the negative 18th, but that's not a simplified answer because we don't ever want negative exponents. But yes, theoretically, it's the same as if there was a y to the negative 18th on top. But don't, because we don't want negatives.
Can we put y to the 18th and then right after it x to the 16th? Or is
As long as there's a 1, as long as it's a denominator. 1 over that.
Yeah.
Like you can write it like this. Yeah, that's not wrong. I just always put them in alphabetical order. Look at 21. Because I feel like this one is easy to do weird things on. What would you do first? Plug it into your calculator. Here's the beautiful thing. Your calculator will do this for you, but it's going to give you a decimal. But do you know how to turn a decimal into a fraction? Yeah, math 1. So your calculator could do this whole thing for you. The idea behind it is if it's to a negative exponent, just flip it. 1 over 81 to the 3/4 power. 81 to the 3/4 power is the 4th root of 81, and then take it to the 3rd power. But like I said, your calculator will do that for you. 81 to the 4th power is 3. 3 to the 3rd power is 27. So this is 1 over 27. Okay. Ooh, 18. A lot of you did this one wrong on the quiz, or this type of problem wrong. What do you do here?
Put the 1/2 to the 64 into those negative 8.
Right. What is anything to the 1/2 power?
Divide by 2.
Not divide by 2.
Oh, this
It's a square root, right? So 8 to the negative 1, or to the 1, negative 8 rather, to the 1/2 is a negative 4. Again, your calculator will do it for you. Plug in 64 to the 1/2 power, and your calculator is going to tell you that's 8, okay? But it is the same as saying the square root of 64. So 8, and then x to the negative 4th, what do you do with that?
Flip it.
You got to flip it. So you need a denominator of x to the 4th, right? That's got to move down because of the negative. How are we doing? Let's look
Why
at,
do you put a square root over 64?
I mean, you can plug that into your calculator and you don't have to put the square root there. I'm just telling you anything to the 1/2 power is a square root, right? This is the root, this is the power. So 64 to the first power, square rooted, is the same as 64 to the 1/2. Look at 16. What is the 1/3 power doing? Cube rooting. Again, your calculator will do this for you if you know all the right buttons to push. But you're saying the cube root of 3 times the cube root of 9. Can you multiply those?
Yeah.
So that's the cube root of 27. What is the cube root of 27?
3.
It's 3. Okay. Okay, let's do some inverses. 13 and 14. You are using these functions up at the top. I'm gonna pull them down here. Okay, so find the inverse of f of x, right? F inverse of x. When you find an inverse, you're treating your f of whatever as a y, right? So it's like saying y equals 5x plus 3. How do you find an inverse? You swap your x and y. So instead of y equals 5x plus 3, it's x equals 5y plus 3. And a lot of you did that on your quiz, but then you stopped. What do you have to do from here? You need to isolate what? Right, solve for y, okay? So you're going to take away 3. So this is x minus 3 equals 5y. And then you're going to divide by 5. So f inverse of x is, I'm going to just write it here, is this, x minus 3 over 5. Okay, now this is the one that you all did wrong on the quiz. If this is g of x and we want the inverse, here, let me show you what a lot of people did wrong here. The equation itself is like this, y equals x squared plus 2. A lot of you, when you switched x and y, you took what's happening to x and y with it. You can't do that. You just switch the letters. That's it. Don't move the squared. Don't move anything else. Just switch your letters. So if it was this, now it's going to be that, right? Swap your x and y. Don't change the format. How do you solve for y? Take away 2. Okay, so this is x minus 2 equals y squared. And then you do what? Square root. What happens when you square root? Plus or minus. So when you square root both sides, you get plus or minus. So this is, that's not f, this is g. Okay, so the inverse of our g of x function is going to be plus or minus the square root of x minus 2. And again, I don't care if you leave it as y equals, that's fine. But it is the inverse of your g function. Look at number 12. What's the domain for this function? Who said that? All real numbers, right? You can plug in any value for x, negative 70 million or 2.5, right? So the domain is all real numbers. What's the range? What does this look like as a graph? X squared plus 2. It's a parabola. Yes, Zach's got that. Where has it moved? Up 2. So if this is my graph, right, 1, 2, my parabola is going to look like this. So what are your possible y values? Greater than or equal to 2, right? So your y has to be greater than or equal to 2. Okay, so if there's an x squared in your function, it's not going to be all real numbers for both of them. It will be for your x, but your y is not going to be, okay? This would be a line, so all real numbers. This would be a line, all real numbers for both of them. But if it's not a line, then you got to think about what does that graph look like? What would you get from it? Let's look at number 10. 10 is f of h of x. What do you do first? The inside, the h, right? So we're going to look at h of x. What do you do with that 2x? Plug it into the f function, right? So you don't do anything on the first step if it's a variable right here. Well, unless your variable is different than the variable given. But there's no like solving to do, okay? So if h of x is 2x, then I say f of that 2x will equal, and it's 5x plus 3. So it's 5 times 2x plus 3. That means 10x plus 3 is f of h of x. Okay, you tell me, what functions do you want to see? This is, remember, addition, subtraction, division, multiplication. These ones are where you're plugging values into your functions.
Can you do number 8?
Yes.
Or 9, I don't care.
So 8 is g of f of 0. Do you do the g of x function or the f of x function first? F. You do the inside one first. So you're plugging 0 into f of x. So f of 0 is 5 times 0 plus 3. So 0 plus 3 is 3. Okay, so that's the first part of it, but we're not done because now we plug it into what? The g function. So we're going to say g of what value? 3. G of 3 is 3 squared plus 2. So you take this g of x function and you drop a 3 in. Okay? So that is 9 plus 2, or 11. Good on that? Yeah. Number 2? Yes. So 2 is h minus f of x. So that means you're taking h of x, which is 2x, and you are subtracting f of x, and f of x is 5x plus 3. You do have to put parentheses around it because we're subtracting the whole function, right? So it's 2x minus 5x plus 3, okay? When you subtract that, what happens? Distribute that minus 5x and minus 3. Okay, so it's 2x minus 5x minus 3, which is a negative 3x minus 3. And that's as simplified as you can go. Yes. 3 is division. So g of x is x squared plus 2. H of x is 2x. It's tempting to try to divide by x, and it's tempting to try to divide by 2, but if you can't do every single piece of it divided by x or every single piece of it divided by 2, you cannot do it, okay? So this is actually your answer, but then x cannot equal what? 0. Here's the thing. All you do is you set your denominator equal to 0 and you solve, and that's your restriction. So if I divide by 2, x cannot equal 0, right? 0 divided by 2 is 0. Good on that?
Page number 4.
Yes. 4 is multiplying. So you have h of x, which is 2x, and we're going to multiply that by f of x, which is 5x plus 3. What do you do there? Is this foiling? No, what's the word?
Distribute.
It's distribute, right? You're just distributing the 2x. So 2x times 5x is 10x squared. 2x times 3 is 6x, and that's all you can do. I feel pretty good, like you got a little bit of everything. Is there anything like that we jumped over in the later stuff that you want to see? Like give me numbers. I will do whatever you want to see. Yeah. 33. Okay. What do you do here? Divide. It's really easy to go, oh, I'm going to multiply by the cube root of 5xy on top and bottom because that's what we did when it was a square root. These are way harder if you try to do it that way. Divide first and see what's divisible, and then you can work from there. So if we divide, 40 divided by 5 is 8. So now we have the cube, and don't ditch the cube root here, right? It's still the cube root of 8. We're not cube rooting anything quite yet. What is x divided by x? It's 1. It's x to the 0 power, which is 1, which doesn't change any values, right? So the x's just go away. What do you do here? Y to the 5th over y.
Minus.
You subtract them, so y to the 4th, okay? Which means we have nothing left in the denominator. So ditch this altogether. We are working out the cube root of 8 y to the 4th. You see how this is way simpler if you divide first and then do that? You don't even have to rationalize anymore because you got it all out of the denominator. So now you break this into what is a perfect cube root and what is not. What goes on the left? 8 and y to the 3rd. So you have just a y on the other side. So this is 2y times the cube root of y. Okay.
Do 11.
Yep. So f of x is this function, 5x plus 3. What does that look like as a graph? It's a line, right? And any line, so 5x plus 3, if we were just going to 1, 2, 3, it's going to look something like that. Okay? What's the domain of that line? All real numbers. What's the range of that line? All real numbers. Whenever it's a line, it is all real numbers for both parts. Maddie.
Will there be an answer key later today? Like if we do it?
Yeah, I can post that. Remind me as you're leaving to do that, and I'll do it real fast. Yeah, I can put an answer key in. 23. All right. For 23, you can reduce the 6 over 9, right? Both are divisible by 3, so 2 over 3. These you're going to subtract. So negative 3 minus 2 is a negative 5. Does that go on top or bottom as a negative 5? It goes on top as a negative 5, right? We'll eventually move it, but negative 3 minus 2, when you subtract them, that's a numerator, okay? Then you have this one. 4 minus a negative 2 is what? 6, right? A positive 6, 4 plus 2. Again, that's a numerator. From here, now you just do a little rearranging. So it's going to be a 2 and a y to the 6th on top. It's going to be 3 and an x to the 5th on bottom. You have to move that negative exponent down and make it positive. Okay. Mm-hmm. So 20, I would distribute, and again, if you want to let your calculator do that, 3/5 times -15, your calculator can do that for you. That becomes a -45/5, or a -9 when you simplify that. The y is a +15, right? A negative times a negative is going to be positive, so +15/3, which is a +5. So you're here right now. What do you have to do? Move the x. So it's going to be y to the 5th as a numerator, but x to the 9th is now a denominator. Anything else? Mm-hmm. Okay, so 6 is f of g of -3. So you start inside. G of -3 is going to be, parentheses matter here, right? -3 squared plus 2. Okay, so if you simplify that, that's 9 plus 2, or 11. Okay, and now you're going to take that 11 and you're going to plug it into the f of x function. So it's going to be f of 11 equals 5 times 11 plus 3. So 55 plus 3 is 58, and that's your final answer for that one. Good on that?